Alright, this is my solution to getting started with test-driven development. The challenge is to write a fully tested library of units converters. I'm going to create a project with a library of units conversion functions that could be useful to, say, a physicist, a chemist, or an engineer. Project should have two main code files. The library itself, I'm going to call mine converters.py or converters.js, depending on which language I'm in. And the tests are going to be in a file called converters_test.py for Python and converters.spec.js for the JavaScript one. I'm going to use my miles per gallon to kilometers per liter function sort of as inspiration. That was the last project we did. I'm going to make sure I can run my tests from the command line, and I'm also going to practice using linters in my code. Since the library is small, I'm going to shoot for 100% coverage, and as a bonus, I'm going to try to configure my repo to use Travis CI to automatically upload and run the tests in my project when I get done. Okay, the first step before you get started programming should always be to do some planning, right? You got to think about what conversions you plan to include. In this case, I said have 3 or 4, so I'm just going to have 2 different categories, and I'm going to do the conversion in both directions. So the first one I thought I would choose is fuel economy. And one of the things I thought was interesting when I started researching this is that in the US, we typically refer to miles per gallon, focusing on the distance you travel on, say, a gallon of gas, whereas in Europe, it's measured in liters per 100 kilometers, which focuses on the amount of fuel used more and standardizes the distance of travel. So I'm going to have one function that does miles per gallon to liters per 100 kilometers, and then I'm going to have a liters per 100 kilometers converted into miles per gallon function, 2 there. And then I'm going to do some pressure conversions, converting imperial units to international units and vice versa, right? So PSI to KPA. PSI is pounds per square inch. More accurately, pound force units per square inch, and to kilopascals, which 1 Pascal is equal to 1 Newton per meter squared, right? And a Newton is a unit of force. Looked up some useful constants in this case: the kilometers per mile, miles per kilometer, liters per gallon, gallons per liter, newtons per unit of pound force per newton, and meters squared per inch squared, and inch squared per meter squared, right? So I got those in both directions because I thought they would be useful. Next step is to do some calculations by hand, right? Eventually we're going to write automated tests, and we're going to use these sample calculations as the content for our tests. So it's important that you pick realistic numbers, because one of the ways that a computer program can go wrong is when people put unrealistic inputs into it, right? Realistically, nobody's going to be doing calculations with 10 billion pounds per square inch in them. So we wouldn't want to test with a number like that, although computers don't care about the scale so much. But those extreme values might cause problems, but we want to do tests with stuff that's realistic. So for example, a car tire generally has a pressure of 32 to 35 pounds per square inch. Plug that into the formula, cancel out all the units, and we get 32 psi is equal to 220.632 kilopascals. Checked out with Google, and that answer was correct. Average atmospheric pressure at sea level is approximately 101.325 kilopascals. Plug that into the formula, and I ended up with my calculator getting 14.6959525 pounds per square inch. Again, the Google confirmed that that was correct. A car that gets good gas mileage in the United States gets 40 miles to the gallon. So in this case, since the answer is in liters per 100 kilometers, and the relationship is inverted, right? In US units, miles per gallon puts the miles on top, and in the European units, liters per 100 kilometers puts the volume of fuel on top. So the first thing I had to do was invert the miles per gallon and say 1/40th. So 40 miles per gallon is 1/40th of a gallon per mile. Multiply that times miles per kilometers, and all the rest of this, and I ended up with 5.88 liters per 100 kilometers. And that's the equivalent of 40 miles per gallon. And then I looked up some numbers from the International Energy Association. This is one of the international organizations that is most trusted for doing the science on things like fuel consumption. They also track things like the Paris Accords and how well countries are keeping up with their commitments to make improvements to not have climate change be so bad. And so I found out that in 2018, United States fuel consumption actually improved by 0.8% to 9.4 liters per 100 kilometers. When you plug that into the equation, that's actually only 25 or so miles per gallon. Meanwhile, in the same year, 2018, European Union consumption worsened to 5.1 liters per 100 kilometers. When you plug that in, it's 46 miles per gallon. So basically, in other words, in 2018, Europe was close to 80% better than the United States, and their value had gotten worse from the previous year, and our value had gotten better. So the difference was even more stark in years before that. But checked all my numbers, rechecked the math, made sure it's all correct. I've got the equations that I'm going to need, and so this is really useful. If you can avoid having to think about the actual math problem that you're trying to solve, or whatever human problem that you're trying to solve, and you're programming at the same time, you'll make things easier on yourself, right? Don't make it overcomplicated and try to think about all this math at the same time that you're trying to figure out how to write a program. Things will just get really messy at that point. And then before I get started, I want to anticipate some issues. So as I was doing these sample calculations, I began to think about well, do the functions need to append unit labels like miles per gallon or liters per 100 kilometers? And my answer to this question is probably not. We're going to put these calculations out there, these conversion functions out there as a library. Whoever is using the library will know which functions they're using, and they can add the units on after they get the output back, right? And in the case that they're using the results of these calculations as the inputs to maybe some other calculations, then it would be annoying for them to have to strip off any units that I maybe attach to them. So not going to append units here. Second question that came up is, well, then how precise should the answers be? Should I round the output? And the problem here is you don't know how much precision the person who will be using your equations is going to need, right? If somebody's doing this for something like an online calculator or something like that, probably they don't need a huge number of decimal places. But if they're doing science and they want to be as precise as possible, if you round these values before you send it back to them, that could hurt the work that they're doing. So I'm going to go with no. If somebody really wants a rounded value, they can round it afterwards. And so the last question then, caused by that second question, was if I'm not rounding the numbers, how do I know what to test against, right? If I, if I create one of these functions and it gives me an answer with 12 decimal places, and in my test, I'm only testing against, 8 decimal places, my test results and the expected results might not line up. And even though my math is right and the calculation appears to be right, it might indicate that it's wrong And so what I decided here is I'll follow my advice from number 2, and I will just round the results that are coming back from my functions in the actual test itself and compare against that value. That way I don't have to worry about typing out a whole bunch of significant digits in my tests. Okay, so let's get started. So starting with the JavaScript project, we're going to follow the test-driven development process. That means the first thing we need to do is start the project. And to start the project, I'm going to go to my slide deck on how to start a new project. And skip down to the JavaScript part. And so the first thing to do is to create a GitHub repo with an appropriate node.gitignore. Going to my repositories, I'm going to click plus, new repository, and I'm going to call this converters TDD-JS, and a library of units converters following the TDD process in JavaScript. Okay, going to click the box to add a README file. Going to click the box to add a gitignore, and I'm going to select node, N-O-D-E, click that, and click create. All right, then on the next page, going to click the green button, and then click the clipboard. And going to go back to my desktop where I've got my terminal open. I'm going to cd into my dev folder, and then git clone and paste in the GitHub link. Then I can cd into converters TDD.js, and now I can open this in Visual Studio Code. Code.js. Going to go full screen, going to open up my terminal, and now go to the next step, which is to initialize a new node project by typing npm init. So here in the terminal inside of VS Code, npm init, and go through the steps. Package name converters TDD is good, 1.0 is good. Gonna skip the description. Index.js is good. Test command is jest, J-E-S-T. Repository is already set. Keywords, author, license, all going to leave those at the defaults and hit enter. And as you can see, when that's done, it's created this package.json as a new untracked file in my repository. And I can move on to the next thing, which is to set up testing. Now, since I did this slide deck, I'm also going to add a package for linting. Talked about linting in a different video this week, and I want to demonstrate how to get that started and set up. So, in here, I'm going to type npm install --save dev, and then jest for testing, and eslint for linting. Okay, now that that's done, if I open up my package.json file and scroll down to the bottom, I can see that I've got Eslint installed and jest install as development dependencies. All the dependencies that npm installs get put into this node modules folder. This is a special folder, and in general you don't have to open it up, but there is one folder worth mentioning, which is this .bin folder or .bind folder. And if you look inside of that folder, you're going to see a bunch of commands that can be run from the command line by your program. And one of those is eslint, and another one is jest, right? So eslint is for linting, and jest is for our unit tests that we're going to be doing. Now, to get to them, if I wanted to run those commands, I could type /node modules dot bin / and then the name of the program, and this would allow it to run. I'm going to just add a -v to output the version, and you can see that that pops up as version 7.9. So that proves to you that it is executable. Now, I've set up my computer so that it will automatically look in that node modules.bin folder whenever I'm in a Node.js project. If you're interested in knowing how to do that, I can show you in another video. I'm not going to explain it now, but if I type which Eslint, suffice it to say, it'll show up as the one that's in node modules.bin Eslint. Okay, so how do we get linting set up and configured for this project? I'm going to go to the web and type how to get Eslint configured. And the first thing that comes up is configuring Eslint. There's another one, getting started with Eslint. These are both the Eslint official docs. So let's open up this one. I strongly encourage you to read this documentation all the way through. There's a lot of stuff there, but Eslint is pretty powerful, and there are lots of different things that you can do. So if we take a look at this other documentation, we get an even faster one. So this getting started with Eslint walks us through the process. So we already did this part, npm install eslint -- save-dev. That installs it as a dev dependency. And then once we've done that, we can do eslint -- init to initialize our configuration file, right? And they use npx. We can actually just type eslint -- init. And so I'm going to type eslint -- init at the command line, and it's going to ask me some questions. All right, so how would you like to use Eslint? And I can use the arrow keys to navigate around, to check syntax only, to check syntax and find problems, to check syntax, find problems, and enforce code style. Remember, linters are great for teaching you how to write code with style. So I'm going to choose this last one, hit enter. What type of modules does your project use? JavaScript modules, CommonJS, or none of these? We're going to choose the first one, JavaScript modules. Which framework does your project use? React, Vue.js, none of these. In this case, none is the correct answer. Does your project use TypeScript? No. You can use the right and left arrow keys to toggle those, but we're going to say no here. Where does your code run? Does it run in the browser, or does it run in Node? Well, browser is inside of a web browser like Chrome or Safari or Firefox. Node is at the command line. This one is going to run at the command line. So I'm going to hit the space bar to uncheck browser. Mouse, hit the down arrow key to go to Node, hit the space bar to check Node. And then it says, would you like to define a style for your project? You can either use a popular style guide, answer questions about your style, or inspect your JavaScript files. Let's use a popular style guide. And the choices that it gives you are the Airbnb standard, standard JavaScript, and Google. Let's choose standard. And what format do you want your configuration file to be in? This is going to be the JavaScript format. And so it's going to check to see if we've already installed all the required dependencies in our project, because it may need to download some additional code, and it looks like we need some. And so it says, would you like to install them now with npm? I'm going to select yes and hit enter and wait for those to install. Okay, so you can see here that the package.json file got updated, and it added a whole bunch of Eslint package dependencies, Eslint config standard, the import plugin, the node plugin, promise plugin, and the standard plugin. And all of those will support the style of coding that we want. So now it also created this file, which you can see it's got a U for untracked yet here, .eslintrc.js. And that is a special name of the configuration file that Eslint uses. I'm going to go ahead and open up that file. And when I do that, VS Code prompts me and says the Eslint extension will use Node Modules Eslint for validation, which is installed locally in the Converters TDD.js project. If you trust this version of Eslint, press Allow, otherwise press Do Not Allow. Press Cancel to disable Eslint for this session. It's possible to have Eslint installed globally on your system, but in order to make sure that your project and your version of Eslint are in alignment, I recommend that you install it locally in each project the way that I've showed you here. And yes, I trust it, so I'm going to click Allow. And now you can see the Eslint configuration file. Now, to understand this configuration file in all of its detail, you're going to want to go back to this page, which has the documentation for configuring Eslint so that you can understand all of the things that are here. But for today, just to keep things shorter, I'm going to go through and add a couple of rules and also tweak a couple of settings. And these are settings that I know about because of past experience working with Eslint, and ones that over time I've developed as my own personal style. Okay, so the first thing here is the environment, right? And by default, it's set up ES 2021. ES is short for ECMAScript. ECMAScript 2021 means all the latest features of the JavaScript programming language will they be supported, and you say yes, they're true. It also has Node true because we are going to be operating in a Node.js environment. I'm going to add a comma there at the end because I always like having trailing commas, and you'll see I get a little red squiggly and it says unexpected trailing comma. Well, I like having trailing commas, so I'm going to go down to the rules here, and I'm going to add a rule, and the rule is comma dangle. And if I don't have a dangling comma at the end of my objects, I expect an error to be thrown, and I always want the dangling comma. And I'm not going to explain what that is right now, but I encourage you to go read it, read about what this rule is, and you can look that up in the Eslint documentation. Now I'm going to hit Command S to save this, and you can see that because I added this should be comma. Because I added this comma dangle rule, it's going to flag it if I don't have a trailing comma. And you can see here, 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 it is missing those. If I hit save again, it's going to auto fix them because I've got Eslint set up to auto fix errors on save. So it went through and it found those errors and it fixed them. All right, so I need to add one more environment here, and the environment I need is Jest. And Jest is our testing environment, and if we don't put Jest as one of our environments in our ESLint.rc file, then Visual Studio will complain about syntax errors in our testing code. So we want to make sure that we add that in there. We're extending the standard rules, right, which is the standard formatting. And down here, there's a rules section where you can add in your own rules. So this rule that we've got here requires commas after every array element or name value pair in a JSON object. So I'm just going to put that little explanation that's in there, and I'm going to add a few more rules here. Enforce two-space indentation, and the rule for that is indent. And I want to throw an error. Oh, this needs to be in quotes. I want to throw an error, and I want it to be set to 2 spaces. So unless there are 2 spaces, it will throw an error. I also want to make a rule to never allow unnecessary semicolons. And this is a rule I adopted because I do a lot of coding in the Vue.js community, but I think it's probably more common in code that you'll see online that people do use semicolons. But I am used to not typing them. So I'm going to type semi and add an array and say error never. And what that means is that you should never use semicolons at the end of your lines unless they're necessary, and there's only a couple of cases when they are absolutely necessary. Otherwise, it'll give us a warning, and also it'll fix those errors if it can when saving. Alright, so now that that's done, I can do Command S to save that, and should have my Eslint configuration complete. Now you'll see Eslint in operation as we begin to write code. Alright, so back to our slides. We set up testing, and the next thing that we need to do, the next thing we have to do according to our list is to write and run a smoke test. So I said in the instructions for this that I want to create a file that is called converters.js, and that's where our units converter functions are going to go, and the tests for those functions, converters.js, and the tests for those functions are going to go into a file called converters.spec.js. Now the file name here is specifically chosen when you want to run, when you use Jest to run your tests, it's going to look for files that have .spec.js or .test.js at the end of them and look for tests inside of them. So I'm going to create this file called converters.spec.js. So inside of here is where I can begin to write my tests. Now, if you've never written tests with Jest, I strongly encourage you to Google something like writing tests with Jest tutorial and find one of the many online tutorials for writing tests with Jest. I will show you the bare details, but we're going to be following the describe style of writing tests. And what I mean by that is I'm going to type describe, and as you'll see here, as soon as I start typing that, I get a pop-up which is saying, gives me a bunch of options for automatically generating a block of code to create a describe block. I'm going to go ahead and hit enter and allow that to happen, and this block of code pops up. Now the reason that this happens is because I installed an extension called Jest Snippets. If you watch my other video on getting the most out of VS Code, I show the installation of that Jest Snippets extension, and I talk about extensions and how to install them and why you want to install them. One of the main reasons is it can generate a lot of your code for you just like this. So what are we describing? We're describing a library of units, conversion, let's just call them units converters. All right, and in this library, we're going to start with what's called a smoke test. And so we're going to say it can blow smoke. And I'm going to finish off the template code here. Now a smoke test is a very, very special kind of test. With a smoke test, it doesn't actually test any other code in your project. The purpose of a smoke test is to give you proof that your testing infrastructure is set up correctly. So in this case, it's supposed to give you proof that Jest is installed and that you can run your tests from the command line. So what we're going to do is we're going to say that we expect true to be true. And essentially, I'm going to go ahead and save this. And you'll notice when I do so that those little red squigglies went away. Those were syntax errors or stylistic errors that Eslint found and fixed for me, right? And so I said I should always have dangling commas at the end of lists of things like the arguments in a function and the elements in an array or in an object. And so it's going to add those in here. And now I can try to run my smoke test. So I'm going to go down to the command line and I'm going to type npm test. Hit enter. And you can see that I have a passing test. A library of units converters can blow smoke. I have one test suite. When it says suite, it's referring to one block that is surrounded by a describe section. And then within that suite, I have one test, that passed, and you can see the output here. Now, what does it look like if it fails? Let's go ahead and change this to false and run this again. Actually, I'm going to show you another way to run it. So I'm going to save this, and now I'm going to type Shift Command P and type npm run test, right? And you can see here that you can even do that by doing Command RT to make your test run. So I'm going to hit enter here, and it will run my test. And now you can see that the test failed. And it's going to show you exactly where it failed. It says a library of units converters can blow smoke. Expected, the value that it received, to be the expected value. Expected false, right, which is what to be true. And so here it even shows me the test that failed, and gives me some messages. And this is essentially what Jest does, is it allows you to write tests. So I'm going to go back and change this back to true so that we know that it is the correct thing. I'm going to save it, and then I'm going to do Command R and then T, and it will run the test for me in the command line. So I used the keyboard shortcut that we learned just a second ago, which is Command R, or on Windows I'm guessing it's Control R, and then once you type that, it will wait for you to type another character. In this case, T. Command R is for run an npm thing, and T is to test. And that is a set of functionality that you get by installing the npm extension for VS Code. That won't work in VS Code right out of the box. You have to install the extension. So if you haven't, again, go back and watch that video on how to get the most out of Visual Studio Code. Okay, cool. So if we go back and look at our how to start a new project, right? We ran our smoke test, and then we need to do an add commit push, and then we can begin the TDD process. So I'm going to go in here. You can see here now that I've got 1, 2, 3, 4, 5 different untracked files in my repository. So I'm going to do git. All right, first we can start with the git status, and it'll just show us that there are these 5 files here that are untracked and that our repository knows nothing about them. And we do git add dot to add them. Now if I do git status, they're all green. They are being tracked now. You can see they've all changed from U to A for added, and they're new files. And so now we can commit them, git commit -m, and we need to add a commit message. So Eslint config, and then say smoke test. Okay. All right, so that summarizes what we just did, which was to configure Eslint and to write a working smoke test. And if I see that commit message in my commit history, I'll know that exactly what happened when I did this. All right, so I've committed those things. You can see that all of the file names changed back to white and the letters went away. If I do git status again, you can see that I'm on the master branch and that I'm ahead of the origin master, which again is the version of the repo on GitHub, by 1 commit, and that I should git push to push those changes up to the remote repo. Let's do that now. Git push, and those will now be up in GitHub. Okay, so at this point we are ready to begin the test-driven development process. So if we look at our slide here, we've done the start part, right? We've gotten everything set up. So the first thing that we do now is to write a failing test. Well, what should our failing test look like? Let's go here and look at our sample calculations and start with our first one, right? It should be able to convert PSI to kilopascals, right? That's the first test that we have in here. So let's go back to our code and let's go down, open up a couple of lines here, and we're going to write a failing test. So if I type it and hit enter, then the just snippets will add an it block, right? And think about this in terms of sentences where the beginning of the sentence is up here. A library of units converters, and you could say should be able to, or should convert PSI to kilopascals, right? And down inside of here, then we are going to expect that a function, and we haven't really named our functions yet, but it's important for you to understand here that since we start by writing tests, this is a good time to pick the function names that you want to use. So eventually we're going to write a function to convert PSI to kilopascals. So what is a good name for that? How about PSI to KPA? We're going to have a function called PSI to KPA, and if we pass in a value to that, and I think that the value from our slide was 32, right? If we pass in a value 32, we expect that to be a value here, and the value that we're expecting is 220.632. So let's put that 220.632. All right, I'm going to save that, and already we have a warning, right? So there's a little red squiggly. Whenever you see squigglies in your files, right? Red, yellow, green, blue, whatever color they happen to be, if you mouse over them, you'll get a little tooltip which explains why it's there. And what it says is PSI to KPA is not defined. And you can even here, if you mouse over that where it says no undef, that's no undefined symbols or functions or things like that are allowed to be used. Eslint found that. If I click on this no undef, it will actually take me to that rule in the Eslint documentation, and it will explain with examples what that rule is, how it can be configured, what it means. Usually these rule explanations are not very long, so I encourage you to start reading them and learning what they're about if you don't know. But in this case, we kind of should, if you think about it, know what the problem is. This is a function that doesn't exist yet, and therefore it's not defined. But remember our process, right? We're going to write a failing test. So we don't know that it for sure that it fails yet until we actually run our tests and watch it fail. So I'm going to do Command RT, watch down at the bottom, and you'll see I've got one failed test and one passed test. If you scroll up, you'll see a library of units converters can blow smoke. That test passed. But then there's a check next to that one. Then there's X next to should convert PSI to kilopascals. And you can see here a library of units converters should convert PSI to kPa. And you'll notice, like, the way that I've written these tests, this text here, this is just descriptive text. And if you write that correctly, even a person who is not technical, like your client, if you're building software for a client, even someone who's not technical should be able to understand that test and tell you if it's a good test or not. And it's a reference error. So it says PSI to kPa is not defined. And of course it's not defined. We haven't defined it yet. So this takes us to our next thing. So we've written a failing test and we watched it fail. Now we want to write code to make it pass. And again, here you want to do the simplest thing that could possibly work. So let's see what the simplest possible thing is. All right, so we know that we're going to put the code with our functions in it in this converters.js file. In order to get a function out of one file and into another, you have to export it from one place and import it into another one. So we need, before we use it in our test, right? Import necessary functions. So in this case, or we can say import functions to be tested. So in this case, we want to import PSI to kPa from converters.js. And since it's in this directory that we're in now, it should say /converters.js. Now you'll notice here that it's got a little red squiggly. It says I'm missing my trailing comma. So I'm going to add that. And now that is ready. So now look, the little squiggly down here that said that PSI to kPa was not defined, that's not there anymore, because at least from the perspective of this file, it sees that it's been imported and it thinks it's defined, even though we know it has not been defined yet. So let's go ahead and run our test again and see what happens. So our test is still failing. And now it's saying it encountered an unexpected token. Okay, you should read these error messages. They almost always give you a clue as to what's causing a problem. And I know that they can be long and intimidating and use a lot of jargon and a lot of technical words, but there's no way to learn these words but just to look them up and try. And there's just way too many of them for me to have a class and a lecture and a video about every single one of them. And this is how programmers learn, right? We spend time stuck, about 90% of our time being stuck, as a matter of fact, and you just got to read these things, right? So this usually means you're trying to import a file which Jest cannot parse, i.e. it's not plain JavaScript. By default, if Jest sees a Babel config, it will use that to transform your file. Here's what you can do, and it's got some things here, and it says details. Syntax error, cannot use import statement outside a module. That's interesting. let's try a slightly different configuration. So there's another way to do these imports, and for that I can do const psi2 kpa equals require converters.js, and I'm going to comment that one out. Whoops. Require. And again, I need my trailing comment here. Let's try that. Squigglies are gone. Let's run the test again. Okay, so the test failed again, and it said, what? PSI to KPA is not a function. Okay, so the import error is no longer an issue. Now, let me say I'm not going to go in depth into the description because this would deserve a whole video unto itself. But this is one style of importing functions in JavaScript. This is the new cutting edge way. This is another way of importing functions in JavaScript. This is the older, more tried and true way. I tried the new way first, and it turns out that it's not supported in this particular architecture. So the old way worked, and so I'm going to delete the newish way and just leave the one that works. And the reason that you have these differences is that the new features in JavaScript come out all the time, right? There's always new things being added to the language, but it takes a while for web browsers to catch up, right? So if you think about people using Safari and Firefox and Chrome and all the other browsers, it takes a while for the browsers to actually implement the features of JavaScript, and it takes even longer for people around the world to actually update their browser to a version that's recent enough to use those things. So in order to be safe, when you're doing JavaScript, you frequently have to use slightly older versions of the language or slightly older features just to make sure that everybody who wants to run your JavaScript in the browser will work. Now in this case, we're not actually running the JavaScript in a browser, right? We're running it at the command line with Node, and so this caution that we're taking here is not 100% necessary. But I don't want to get into that in any depth today. This works, let's go with this. All right, so the problem we got is that the PSI to KPA is not a function, and that's true because we have not created a function yet. All right, so I'm going to do Command P and select converters.js to open up the converters.js file, and then I'm going to create a function called PSI to KPA that takes a parameter PSI in as input, and then it's going to let's go ahead and put the documentation for this. So if I do /*, you'll see here that I get a pop-up which says it'll write our thing for us. The param PSI is a number, and it is the input pounds per square inch value, and this is a function to convert PSI to KPA, right? And it also is going to returns a number, and it's not strictly necessary that you write this documentation just like this in this format. It's a good habit if you learn the JS doc format and you know how to do it. It's a really, really good habit to get into, and it's also not necessary that you line everything up in the way that I'm lining up. But I want to show you what it looks like when people take their time and are conscientious and really try to pay attention to all the details. This returns the PSI converted to kilopascals. All right, so that means down here that we need to do the conversion conversion and return a value. Return, and I'm just going to put 0 for right now, just so that we can have something. Now, here we got a little red squiggly that says the input pounds per square inch value, right? Returns this. PSI to KPI is defined but never used. And this corresponds to a rule, no unused variables. And you can see here that because of that documentation I wrote above, it's already converted it into some documentation here. That means somewhere else in my program, if I used this function and somebody moused over it, they'd actually be able to see these sort of instructions for how it works. Let's go ahead and export this function, right? Because remember, if you want to import it, and that's what's happening here, if you want to import something, it has to be exported from somewhere else. So I'm going to do module.exports equals, and I'm going to type PSI to KPA in here, put my trailing comma, and save this. Now you can see that all of our red squigglies have gone away. Eslint added some spaces around here, and so now we have created a function. It's being exported. Now it's being imported into here. Let's run our test again and see if that works. Okay, didn't expect it to work, but let's see what the error is now. Okay, so actually, right, a library of units converters should convert PSI to KPA. A library of units should convert PSI to KPA. It expected 220.632, because remember that's what we said in our test, right? We expected 220.632, but what it received was 0. And if you look at the function, that's because we just put return 0 there, right? That's because we haven't written anything to do the conversion yet, and we just, as a placeholder, put return 0 in there. But this is good, because we know that because there's a 0 here, that means that this function was actually executed in the test file, and that the value that it got was 0. Excellent. So we're making progress. Now, here it says we're still at this step where we're trying to write just enough code to make the test pass, right? So we've written a failing test. Now we need to make it pass. So we know that we can return a value, and we know that in order to pass, it's expecting to get the value 220.632. So the simplest thing that could possibly work would actually be just to return 220.632. Let's save that and run the test again. And look at that, it passed, right? It passed because, right, we know that what it was expecting, we just passed that number. The problem with this, obviously, hopefully you can see, is that no matter what PSI value we pass in here, it's always going to return 220.632. Let's go back and update our test to add another value so that we know that it can do, at least one more value. Let's pick another. But I'm going to use Google to do PSI to KPA, and let's say, well, let's just do this one, right? If it gets 1 PSI, then the KPA value should be this. So let's copy that, and let's add another line here. PSI to KPA, pass in 1. The value that comes out should be this one. Let's save that and run the test again. Now our test fails, and if you scroll up, you'll see that expected to get 6.89476, and instead it got 220.632. And that's because our converter function always returns 220.632. It doesn't actually do a conversion. But you can see here that it failed on this line, which means that it actually passed on this line. Right? So you can actually see exactly what line failed, and exactly where and why. And this is why using unit tests in your code is so powerful. Okay, so if you are in our process, we've written enough code to make it pass, and now we're at the refactoring stage. So now is where we go back and we make it work. So let's remember what our function is, and the function uses some constants, right? And let's go back and add our constants to this file. And just to make it easy, I think I'm gonna see if I can copy this stuff and go into my converters.js file. I'm gonna go up to the top, and I'm going to paste all that code in there, right? Or this is not code actually, but this is the text from our slides, and I'm just going to put it in there and comment it out, and I can use that so I don't have to keep switching back and forth to the other file. Now I will go up to the top. We'll go up to the top of the file, and I'm going to add a document block. This is, we don't need parameters here. This is not a function. This is just going to be converters.js, right? This is a library of units conversion functions, right? And that just explains what's in the file. So the first thing we want to do is we're going to create necessary and useful constants. So let's start with const kpm, and that's 1.60934, and this is kilometers per mile. All right, now we get a little red squiggly. What is that for? That's because it's declared, but its value is never read. It's assigned a value, but never used. That's fine. We will use it later. For right now, we just want to create our values. And so let's just declare these one at a time. Const. Okay, so I have created all of the constants. I went and got them from, where I had looked them up originally to do my research. Now I can begin to use them in my functions. So here we've got our first function, which is the function to convert PSI to KPA. Before we do this, let's run our test again, just to make sure that it still fails. If for some reason it passed now, after we just entered constants, that would be weird. But yes, it still fails, and it's still passing 220 point something when it should be getting 6.84976. All right, so let's do the conversion and return. Actually, we can just combine doing the conversion and the return step into one. Let's say return the converted value, and we're going to return the PSI multiplied by what? Multiplied by newtons per pound foot. So look at our table of constants above. That's NPL, right? Newtons per pound force times inches squared per meter squared. And so that's inches squared per meter squared is IPM. And as we have here, that gives us pascals. And so in order to get kilopascals, we have to take pascals and divide by 1,000. So let's take all of that and divide by 1,000. And if we were, another thing we could do here is we could, to make this even better documented, might be to actually put the formula up here in the description of the function section. But I'm going to go ahead and save this, and I'm going to run our test. and now it is still failing. Well, geez, that's surprising, right? Because we've put the function in. Shouldn't it be giving us the values we want? And so let's see what we get here. It expected to get 220.632, and instead it got 220.631712. Oh, gotcha. Right? It expected to get this value and it got this one. That means it's getting a value with a lot more precision than we were expecting. Now there's a couple of things we can do here. One thing we can do is, okay, well, we know that at least for this particular value, the conversion is giving us a value basically with some rounding error. It's giving us the value we expect. We could take this exact value, 631712, copy that, and we can put that in our test. Now, in general, you don't want to update your test to match the you don't want to update your test to match the output that the function is doing. Rather, you want to make the function output what the correct answer is. But in this case, when we're talking about this precision value, let's just try this out. So I'm going to run the test again. It still fails. And where does it fail? Okay, this time that first conversion, converting 32 to 220.631712, that worked fine. Now we're having a failure in terms of the precision of the second equation. So let's fix that one. 894.741. Now this is a value that we looked up online. So let's say 7476. These values are not, this is not due to a rounding error. So this is the kind of this is why we do the calculations ahead of time, because these values are off by more than just a rounding error, right? 7674, even if we rounded this up, which we shouldn't, these are not the same number. That means that this number that we expected, that's the number that we looked up in Google, right? That's this number here. That's this number here that we looked up in Google. You would think that that's going to be the correct result, but it's different than the one that we got. So what does that mean? This is important to think about, because this is exactly the kind of place that in big scientific programs, being off by a little bit, can, particularly for engineering problems or chemical reactions or things like that, if you're writing software to automate those kind of processes, precision matters. In other cases, maybe it doesn't matter so much. If this was some sort of financial calculation, we probably don't care beyond 2 decimal places. So let's take a look here at our function, and we know that our equation is correct because we're getting an answer that's almost right. And then we've got these values here, newtons per pound force, right? And then we've got the other one that we used, square inches per square meter. I'm going to take these values and I'm going to move them down to be next to each other since they get used together. All right, so we've got newtons per pound force and square inches per square meter. Actually, let's move them up first. Let's move them up to the top of our list of constants, since those are the ones that get used first. Oops, there we go. All right, so newtons per pound force and inches per square meter. Since the error that we're getting seems to be an error in precision. My guess is that these values that we have for the constants are either more precise or less precise than the constant values that Google is using to calculate the value. So let's go ahead and take a calculator. So I'm going to take my phone and I'm going to use the calculator to calculate this value by hand. So it's 1, right, times NPL times IPM divided by 1000. Right, so NPL is 4.44822 times 1550 divided by 1000, and my calculator gives me 894741 exactly, right? So my calculator gave me the exact same result as my program did, but Google gave me a different number. I wonder why that is. Let's look up the constants again in Google. So newtons per pound force. So 4.44822. That is the value we got there, but let's look at another source, because that's probably where I got the value to begin with. Now here we go. The actual value is 4.44822.16152605. So there's quite a bit more precision possible that we could be, that, you know, maybe Google is using when they do things. Oh, that's an image. In this case, they did 222. Let's see what happens if we change this to 222. All right, but it is 4482222. Save that. Run our test again. Now we get 6318112. Looks like we're getting further away from our expected value. Save this and go back and do it again. Okay, so I'm not going to spend a whole lot more time trying to dig into this to try to figure out what it is, what the issue is. What I'm going to do here is I'm going to put a to-do item in my project and say investigate the best possible constant values to explain discrepancy between expected value and what expected value from Google and what our computer and calculator calculated. Right? And so by putting that to do in there, you know, I'm reminding myself that I've got something to do, that I've got to come back and work on that at some point. And I'm going to go grab this value, the 741, save this. I'm going to go in here and I'm going to change this to 741. So I'm going to make them the same. Now this is cheating, right? Technically this is cheating. if I do this in a real live scenario, I could end up causing, massive problems in whatever, software is using these conversions. All right, I'm gonna go back over here, and I've still got, you can see here, I've still got 6 errors because these are all of these constants are created but never used. All right, but let's take a look at our process. Right, we started, we got everything set up, we wrote a failing test, we wrote just enough code to make it pass, and we wrote something that was obviously not correct, but it worked. And then we refactored and refactored and refactored, and we got to a place where our test passes. And if you look at it, it's well documented, it's nice and cleanly formatted. The function itself, we're pretty sure is as correct as we're gonna get it, and we've given ourselves a little to-do item here because we're not 100% sure why it's not giving us the exact same value that Google came up with, but we're content with it. At this point, we're ready to go on to write the next failing test. And we can do it in exactly the same way as we did the first one. So I'm gonna go back to my testing file, and now we're going to, and I'm just going to copy this first test and change this, swap this around. So now it should be KPA to PSI. So let's change these two to KPA to PSI, and let's use the value that we came up with in our slide deck, which was 101.325 as input, and as output 14.6. It's a pretty long value, so let's grab that and drop it right in here. And for right now, I'm going to comment this one out, and you can already see, right, KPA to PSI is not defined. Of course it's not defined because we haven't defined it yet, so that's what we expect. But let's go ahead and run our test. Now we went from having just 2 passing tests to 2 passed and 1 failed, and we know it's going to fail because it's not defined. Let's go ahead and import it, KPA to PSI, and we'll save that. Now we'll try to run it again. Again, we get that it failed because KPA to PSI is not a function. So now we can go over to our converters, and let's grab this guy and copy and paste it down below, and let's swap this around. KPA to PSI, and I'm just going to delete this here, and the number that it gets is KPA, that's the input. The input kilopascals value, and we're going to change this to KPA, and we need to change the name of this to KPA to PSI, and this is not the value we want to return. We're going to start by just returning the value that we're expecting. Again, this is cheating, right? You don't just copy and paste this value in. This won't work for anything other than the immediate thing, and then we have to export it. So let's export it, KPA to PSI, and now when we save that, now we've taken care of all of our squigglies, right? We're still not using any more constants, but we'll take care of that in a second. So now let's go look down here, and let's try to run our test again. And now we made it past, right? A library of units converters should convert kilopascals to PSI, right? And that's this test here. Now, we know that's not working because we just hard-coded the answer. But let's add another test to make this honest, right? So I'm going to change this, and let's go and do something different. Let's say, look at our other, this is PSI to KPA. Let's do it the other way around. Let's pick a value like 1 kilopascal, and that should give us a value here, 0.145038. Now look at this. When I chose 1 here, it gave us this value. And then when I clicked here, it gave us this value, which indicates that this value is equivalent to not exactly 1, but 1.00000018083. This imprecision here in the way that Google does the results could be the explanation for why our functions were off in the last time. But let's go ahead and copy this. It'll be close enough. Let's go ahead and add that as our test. Our test value, right? And save that. So 1 kilopascal should be this number of PSI. And we'll run our test again. And now the test will fail again, and we'll see that it's failing on the second test, right? And it's failing because we're returning a constant value. That's what we expected. Let's go in. Let's find our function. So it's kilopascals times the times 1,000, right? Because we have to multiply to convert pascals to kilopascals. And then multiply times pound foot per Newton, multiply times meters squared per inches squared. So I'm going to go into my function, and we're going to take our KPA number. We're going to multiply by 1,000 to convert pascals to kilopascals, and then we're going to multiply by pound force per Newton and meters per square inch. So times LPN times MPI. And you can see as soon as we do that, these are no longer complaining about being unused. And we'll move them up here to the top of our function. Now, another thing I haven't mentioned in here is you can collapse these blocks of code in Visual Studio Code, and that just makes it so you don't have to do quite as much scrolling. This is the, if you do copy and paste like I just said, you got to make sure that you do the fix everything. All right, so let's save this and now run our test again. And now the difference that we're getting here is really just one of precision, right? 69595249, right? So let's go ahead and grab that number, and now that we're doing, so this is the first one, right? And we're off again by precision values. So I'm going to go ahead and paste that in there. I'm going to do the test again. And now it's the second one that's giving us a problem, and it's again precision. So let's save that, run the test again. All right, so now our tests pass. Okay. Hopefully this is enough to get you started and running down the path, right? We've taken this, we wrote failing tests, we wrote enough code to make it pass. Then we refactored, and then eventually we'll get to a point where we can't think of any more tests, or we've written all the functions that we plan to write, and then we'll be done. I'm going to finish this code on my own, right, with tests and everything. and upload, check all of this stuff into GitHub. But you can see here, these 4 lines that have these here. If I take those out, then all of my errors run away. It's just waiting for me to write the functions that are going to use these additional things. I think I'm going to save, since this has gotten so long already, I think I'm going to save the continuous integration, the bonus part, for a separate video later on.